This is some new material for folks that are interested in RIST. And we're going to be talking about the RIST Advanced Profile. So we have with us today, we have Dr. Ciro Noronha, who is Executive Vice President at Cobalt Digital. And he is going to be introducing us to the RIST Advanced Profile, which is a major step forward in RIST technology. So very glad to have you here, Ciro. Take it away.
Thank you, Wes. So let's see what's happening with RIST Advanced Profile, which was just published. Our agenda for today will be a quick review of RIST simple and main profiles to give you a background and information where we are. Then we will talk about Advanced Profile and the future features, and then the future directions for the RIST AG. So let's start with RIST and simple and main profiles and show you what's in them. A little bit of history. The RIST AG was formed in April 2017. It was actually started in February 2017, but we didn't do anything until April, until NAB. We came, had breakfast, and we actually started working, right? So we had a successful multi-vendor implementation in 2018, released simple profile in 18, then we had main profile, and now Advanced Profile has been released in October of last year, after a long development cycle. So here's RIST profiles and levels. You have simple profile is the basis for everything, where you have all the transport, the ARQ, the multi-link, and what advanced main profile adds to you is tunneling, security, in the two modes of security, encryption and authentication. So that's kind of the 20,000-foot view of the RIST profiles. Let's just jump into the Advanced Profile. So we started with tunneling in main profile, but Advanced Profile provides much more enhanced tunneling capability. So the idea is that you can use RIST for any protocol you want. So you can tunnel any protocol. So that's the baseline. The other thing is transparent fragmentation. So you can carry packets of any size, and then the packet just shows up in the other side. And then mathematically lossless compression. Something that exists for a while is just your zips and LZs that do lossless compressions. You get the data just back. The other thing is enhanced PSK security, so more ciphers for PSK. Instead of just AES, you have Cha-Cha, for example. And something very cool called the direct payload transport, which has a protocol registry, and it gives you can map directly some data types into Advanced Profile, and that reduces the overhead. And then something like called follow attributes, when you have, it's a standardized way, and I know I'm not supposed to use the word standardized, because it's not a standard specification, a common way of conveying metadata about the streams. So the big thing that if you want to have one takeaway from this presentation about Advanced Profile is advanced bidirectional tunneling for anything. So all the protocols, HTTP, TCP, IGMP, whatever you want, even the old RTMP, can enjoy the benefits of RIST on the underlying, and then it's delivered just like it is. So you don't have to change your protocol. Even if you can even run TCP over RIST, and TCP will be very happy because there's no packet loss for it to deal with, so it works very well. So what are the benefits of this tunnel? Bidirectional data flow. The tunnel is in both directions. Reliable transport with RISC and ARQ, and one thing that's done here, which is not done in IP, is fragment level ARQ. So if the packet's too big and you fragment, you can do fragment level ARQ. In IP, you don't get the fragment, the whole packet is gone. So you can do that at the fragment level. Just like main profile, you can do security using PSK or DTLS. And again, since like main profile, you have a single UDP port for basically to keep your IT people happy. One port, that's it, you're done. Let's look at the advanced profile features. Yeah, he's laughing. IT people, you got to deal with IT people. The simpler you make it for them, the happier they will be, the happier you'll be. So technical details, because we all techies here, we got to talk about bits and bytes, right? Base packet format is RTP. And we align that with the work being done by the ST2110/1 group. Header extension for 32 bits to do high bit rate flows, and 1 megahertz timestamp, because it's an RTP profile, we can do whatever we want for that, and additional optional fields for enhanced functionality. So the RTP packet payload is an encapsulated tunnel packet. So you take the tunnel, encapsulate it in RTP. What can you encapsulate there? We have a definition. You can encapsulate an IPv4 packet, an IPv6 packet, a reduced overhead packet from TRL62 from main profile, a control packet, which we define, a direct payload packet, which we define, which is if you don't like the tunnel, you can map the media directly in there, and then the hacker cannot do anything. Actually, we can never say that. They take it as a challenge, right? You can do a layer 2 Ethernet frame. You can just put a layer 2 frame, and then GRE packets. Why GRE packets? Because that's what we use in main profile, so we have a special data type for that. Transparent fragmentation, that's important. Payloads are getting bigger, and then you want to use a bigger packet. There's jumbo packets in the Ethernet. There was a big deal with 100 meg Ethernet. It's not as much now, but we support that. So if you have an MTU mismatch between your local network and the WAN, you got to fragment the packet. IP fragmentation is messy and permanent. Messy because each packet becomes an IP fragment, and permanent because once you fragment, the only place where it gets together is at the other end. So RIST fragmentation is reversible. We do it under the covers, and we do ARQ on the fragment. So packet comes in and comes out of the RIST Advanced Profile tunnel as the single thing that came in. So one thing that makes it less messy is that since we have reordering and happen before the fragmentation, is a lot simpler. And for the tech heads there, it's just like the fragmentation you do for SCSI 104 over on SDI. It's just 2 bits. And I know nobody got that. Lossless compression. Optional LZ4 compression. What's new about that? Yeah, we've been doing that, so we just added that. One of the things that you do with RIST is you adopt technologies that exist and are vetted. So LZ4 compression, well known, you can do that if you want. And that can reduce bandwidth. Of course, if you're sending compressed stuff like video, it's not going to make any difference. So we just borrowed the formats from IP compression. So, more ciphers. Main profile only uses ASCTR for PSK. Now, what we added also ASCGM and ChaCha. And we also added on PSK, we added hashing. So if someone changes your packet, that's one problem of main profile with ASCTR. If someone changes the packet, you can corrupt it. With hashing, you detect that. You absolutely detect that. So it's another security feature. We added hashing. And that's then my next slide, hashing for data integrity. You may not be able to break into the packet, but if you flip a bit, you know that bit is going to be flipped in the decrypted packet. If you put hashing, then you're good, you're golden. So that resolves a possible problem in PSK RIST main profile, which is the lack of hashing. So hashing is optional. Direct payload. What's direct payload? I've been talking about direct payload. Yeah, you can do all that fancy tunneling, but if you don't want that, we have a low overhead way of mapping data into the packet, and it can use as a NAT function for bridging between address spaces. You just take the data and push it in there. How we do that? We create a registration authority for packet payloads. And like everything else today, is registered in an open database in GitHub. So VSF is what's maintaining it, and the registry, well, we should have fixed that. The registry is public, has been launched already. So here's the registry, all the packet formats that are registered, and I don't expect you to read that. It's too small. It's just my way of saying there's a lot of formats registered already. You see the main ones. You see transport streams, and you see SMPTE 2110. That's the more interesting ones. For attributes, it's metadata. It's a standardized, okay, I'm using the word again, standardized. It's a common specification for metadata in the string, right? So we use JSON because it's cool and it's easy to parse. You can label each flow individually. We have time spent temps for version control, and then you include subflows. Why subflows are important? Think about 2110. You have video associated with multiple audio and maybe ancillary data. So subflows of a major constructed flow. It's similar to the pattern PMT. Advanced Profile Levels Annex. It's something that's about to come out. It's done. Yeah, we made this thing so flexible, right? But how do you communicate that? So we have a baseline, and we specify interoperability levels because we made so many options to adapt to different scenarios, and then you need to specify what you support, because if you're doing transport stream, yeah, it may be advanced profile, but it's not going to interoperate with something that does 2110. This is similar to the main profile levels. So here's my level. They are specified as encryption level, encapsulation level, and protection level, because you have options for all of those. For encryption level, you have baseline, DTLS, PSK, and WireGuard. And why is WireGuard green? Because we haven't published it yet. But I'm giving you an advanced version. If this was empty, I would have my hands slapped, right, Wes? All right. The encapsulation level is, so how you carry is one, how you protect it's one. What's in it is the second level, which is the stuff I described to you. And then how you protect it. Protection in this case is packet loss recovery, which can be none. We allow you to do that. You have a very good network. You don't need packet protection. So you have non, ARQ, and the various types of FEC. And 2022-7 is a form of protection because you're using redundant links. So here's an example. Let's say I'm making a system that supports ATLS and PSK. It can do IPv4 tunnels and TS, and it does ARQ and FEC. So that's how you specify it. Pretty cool, right? Or complicated, depending on point of view. Future directions. So I'm showing you here a glimpse of the future here, what we are working on. And here's what keeping the RIST AG off the streets. Receiver synchronization, that work is complete, and if you guys have a conference pass, I'll be talking about that at BITC this afternoon. Work of WireGuard, because, all right, there is other encryption, so we specify the use of WireGuard. It's basically pick these choices and you're going to be interoperable. Firewall traversal is pretty cool technology. It's called we call it the RIST Relay. The work is complete as well. I'll be talking about that at VTrans, so y'all should go to Marina Del Rey in June and then hear about that. And we're starting on the big can of worms control and management for his systems. And the talk before mine, the source adaptation is already done. I'm the editor, and I have all those things in my queue to write, and it takes forever. So you can blame me in the fact that it hasn't been published yet. And then there's the rest. So little bit of fluff, right? Who's behind RIST? Wes is behind RIST. So you see RIST this and RIST that. So that diagram, I've made this diagram last year or the year before, and I always show it, right? You have the tech people here that do all the work, all the technical work. The AG chairman is Rick Ackermans from CBS. The co-chair is Wes, which is sitting over there. We create a risk specification that's approved by the VSF board, and then goes to the marketing people who are going to make noise about that. And that's the risk forum, which I happen to be the president of too. So I got two hats here. Lots of companies, there's over 180, we're getting to be 200. Lots of companies are members of the RIST Forum. So if you're interested in RIST, if you want to adopt it, I urge you to join the RIST Forum so you can get more information. There's website is RIST.tv, and the lowest level of membership is free. And that's that. I realize I talked too fast. If I have any questions, and
What? I'm not going to ask a question. I'm just saying that my experience about tunnels through firewalls is very different than yours.
okay, so you only if you have a tunnel between site A and site B through a firewall, you only are secure as site A and site B. If it gets broken into the other side, they can ride the tunnel back. There's absolutely nothing I can do about that. I give you a tunnel, but you had a tunnel in main profile, and there are some security features. But I know, security is only as good as if you turn on the features. But if you have a tunnel, yeah, you open. So we have something as a tunnel, but if you don't want to use it as a tunnel, just as a conduit, it's fine to work like that if you don't want to have a tunnel. And I know you say tunnel to IT people, they freak out. Oh, there's a tunnel, and for good reason.
Yeah, we need to address those, concerns, but I think Ciro's absolutely right. I mean, just like a tunnel going under a river, if you put water in, the tunnel can stay dry, but you pour water in one end, it's going to come out the other side. Okay, very good. Thank you for your presentation, Ciro.
Thank you.